Сейчас у нас будет еще доклад про то, как сделать магию быстро.
Now we are going
So we'll have another
to
report
have
right now about how to do magic
presentation
quickly.
about how to work the magic fast, cool, and good. We will have two presenters, two Dmitris, two Dimas from the technology stack. Oh, it looks like it is the wrong presentation. This is not our presentation, because this is not a presentation. It's somebody else's.
Спасибо коллегам, которые пришли. Зал пополнен.
Thanks to the colleagues who are here. We see a lot more people here.
Завтра на Дейлике.
And see you tomorrow at Daily. Oh, this one is ours.
Я Дим Зуев.
Yeah, we are going to talk in duet. I'm Dmitry Zuev, and this is Dmitry Malkov, and I'm an engineering manager who is responsible for the EM and data engineering, and Dmitry is our senior data platform engineer. He will talk about what he and his team has implemented. It will be a 50-50 presentation. I will talk about generic things, and Dmitry will present his case. So what I would like to use for this presentation, a year ago, at the Positive Hack Data, the first person to speak was Vladimir Ozerov, who spoke about the state of big data over the past 30, 40 years and how it all developed. And one of his items was that there was the data system management manifesto, and he spoke about what could be a good approach and what interesting solutions could be used to put together the bricks. What I really like is that in LGP, this article is asks Pedro Pereira, and there is also Wes McKinney here, who wrote Arrow, and before that did Pandas. So there are a lot of really significant authors in this paper. How does the Composable Data Management System Manifesto fit in? I believe the main idea of this paper is that we can reduce redundancy via this approach, because we have some prefabricated solutions which match each other quite nicely, and we can use them to build something. One of those is Arrow, as Zhenya said before me, and it can be embedded in a lot of things. This is a default memory layout for big data frameworks, and by doing this, we utilize versatile solutions that can be reused across different systems, and easy start and focus on innovation, which ensures scalability, and then we can use off-the-shelf modular components, and we can focus on what is missing there. Before, you had to go bottom up to build the whole stack. Now you can just tackle the issues that are not there, and sometimes you can take another component, and these are the two main ideas. And the authors look at a lot more, but for brevity, that's how I present them here. What is the issue at hand? The classical stack for big data looks like this. This is a YDB, and the guys are going to talk after me, and they have modularity, and there is the protocol of LDC, and there is a separate query memory processor and distribution transaction management and tablet and all of those things are showed here. But these things are not so easily replaced and substituted, but without hard fork, you cannot replace the components here. Really important components like query optimizer or protocol and the byte grinder, putting it together would be kind of hard. But if you want to do that, you could. Now, what do the authors suggest? They suggest a modular data stack. On this slide, and this picture comes from their paper. It shows that everything can be split into the language layer, the optimizer layer, and the execution layer, which is common sense and not rocket science. And please pay attention to the language. It's not just SQL. And you've got to remember that. It turns out that you can use other tools to handle data, not just SQL data. This is the level of SQL. And whatever you write in SQL or some API, somehow you have to put it into the optimizer so that it comes up with an optimized plan. And here you have the gray square, which shows IR, intermediate representation in between. This is an intermediate representation and substrate. Substrate is the only well-known representative for the IR. There are actually several, and there was a big discussion about that, what are the good and the bad features, and whether SQL is alive or dead. So intermediate representation is the substrate, which is about the logical plan. So we get the optimized plan, and then in the query optimizer, we will feed it to whoever does the execution. And there are different situations. There is something distributed and there is something less distributed. And here you have the library and the vlogs. So this is what will work. Vlogs, the fusion, this will work. And the Spark, for those of you who know it. And the authors believe that you can make up the working solution using these components. I wonder if anyone was able to put it together, but anyways, we tried. Now, this is the first flight. This is Arrow flight and DuckDB. What is Arrow flight? It is a versatile transportation protocol. This is part of Arrow, and this is about optimizing. How can you use minimal locations and how you can put together your components, different components such as Walker's shuffle can be built with the flight. And this is an arrow. It can run through the network, and it is cheap in terms of the location. And this is a connector between the analytical engines and the client apps. A few words about Parquet. Zhenya covered it a little bit, but what's good about Parquet? It has a lot of layers, and definitely what's important, the data is stored in columns, and they use column groups, and inside these columns you have the pages, and this also has incredible photos, statistics for each page group, row group, rather. And through the statistics, you can do a lot of cool things done by the engines, and you can run this group, read it or drop it. Now, Parquet versus Arrow, despite the fact they are very similar in their representation. In green, you see the Parquet page and the definition levels and non-null values. You have definition levels and non-null values. In Arrow, you will have the values vector and the null vector. It is easier to move between the two, to migrate between the two. What is DuckDB? This is something that can be embedded. SQLite is used in iPhones, and SQLite was used by smart guys for analytical data and a lab, and they were tackling the issue that the distributed engines up to a certain level don't need. You can process a lot of things on a single node, but there wasn't a convenient one, and DuckDB was in release. 2 years ago, it wasn't in release. It works as a library. It's a processing story. So you have a program in the language that you like, and you raise your in-process to the database. And this is zero dependency, which goes counter the module principle. And it doesn't have the dependency of everything in one repository. And DuckDB unites more things than we would like to see, but this is done because DuckDB has the language, the optimizer, and execution engine, and this is it. That the intermediate representation evidently is there, but it's their own. Why so? Because they focus not on versatility, but rather specialization. What are optimizations you want to pay attention to, and why we selected DuckDB for our solution? This is good joint pre-watering, and we have a DDC built on the dynamic programming. This is really cool. Read about that. And the expected features and partitions. And in March, they also entered the blue filters, and everything will work. It's not an optimizer, but an important thing for DuckDB is that the memory will uses buffers, and without an allocation, you can move them to Arrow. And Dmitry, now you can talk about our case. Okay, now let's talk about the implementation of Aeroflight and DuckDB, and we'll start with explaining why we wanted to do all of this. And we have a data lake on S3, and we have differently formatted data there, and the data is in an iceberg format primarily, and definitely they have Parquets under the hood, and we also have an RS catalog for metadata that it keeps, and we have data sets there. And our goal is to make sure that on demand they can be downloaded in a laptop. You could do that. And we also have certain limitations. The security part is not to be ignored. And we also think about savings. If there are no queries, why would we keep everything going and have the workers there? And we also need the versatile API to integrate with various analytical systems. And the first thing that comes to your mind is, why don't you use Trino, Iceberg? It can read it, it can work with Parquet, it supports Iceberg REST catalog, but the downside is that it is too heavy for us, and there will be a lot of data between the workers and planning, and we just need to download the data set. And also, when we use Trino, we will have JSON, and it will be converted, and it doesn't look really good. And DuckDB as the second candidate, and Dima has already enlisted a number of upsides. It is easily embedded in any code in different languages, AC, Python, Java, and Rust even, and it supports Iceberg and Parquet, and there is an integration with an RS catalog, but this is also a downside because it is new, it is a preview, and they are implementing it their own way, and you can save resources with it because you don't have a lot of workers, you can control it, and I will explain how. And it looks like DuckDB is good, but we have to improve it because the downsides we have there are that the security is not very transparent. You need a token for S3, for RS catalog, and it's not really clear how to simplify that and streamline that. This is a versatile IP, and we are not just providing DuckDB. Just so we need a contract. And DuckDB, if you add an arrow flag to it, it looks like all of those downsides are mitigated. We will have an API so that we add more security and also the isolation, and also the integration with the RS catalog. And now let's talk a little bit about Arrow Flight. And I'm not going to cover Arrow at length because Zhenya has covered that already. If this wasn't enough, you can also have a look at the presentation, catching up with speed from G-Point. And so it is Arrow plus GCPT, because this is Arrow. It has 0 copies for the level of gRPC. This is a well-described standard. And basically in any language, in any popular language, because this is gRPC, you can do the implementation of this API. And we have all the advantages of Arrow here. And what can Flight do? It can do several things. It can get data and the do get, the do put, doing the exchange in one operation that is two streams, and also additional operations that are needed. To begin with, to initiate the protocol, to get the schema, the list actions, the do action, etc. Additionally, and this is done for Arrow Flight SQL. Now let's have a look at the do get. This is one of the implementations. What is happening here? The client sends a descriptor, and this is a command or a path to the data. This is a key to the metadata server. We know where everything is and where the data server is, and what it is sending back is a certain ticket that you have to send, and also the address of where the data is, and there is the communication between the data servers, because this ticket should show that this is the data to be identified, and we get to the invoice, we go to the data server, and we get batches, and this thing can also be decoupled, not in parallel, and the data can be broken in further chunks, and several data servers can operate, and we can to get and put in parallel. And the metadata server knows something but cannot respond because it's not ready, or additional computations are needed, and several data servers are needed. And then it's not about get info. We are sending several queries, and if we get an empty endpoint, we have to request once again. And when there is a specific address, then everything is good. We have spoken a lot about DuckDB. It's easily embeddable. It works well with Parquet because there is zero dependency, and we can take it on without additional libraries and use it. There is no incompatibility. The only issue is that it is implemented differently on different catalogs, and it can work with Parquet, Iceberg, and other catalogs. This is written with C, and this could be a downside if we are using Java. And now let's have a look at how we put all of this together. And this is a flow diagram, and we have the same we have a metadata server and a data server, and we have a client here. And the client is sending this. It sends the CR, and then they create the instance of the data server, and it is ready to process data, and and we get the metadata server message that here is the ticket, and the client knows here is the address. They send the ticket, and they get the stream of specific data. If we put all of this together, on a component diagram, you will see exactly the same. So here is the block chart of this. The only data I added here is the metadata server talks to the catalog. I want a certain data set in certain space, and probably you could see that there is no security. I removed it for simplicity reasons. But the security part happens here too. We have an identity provider. The token is checked, then it is checked with the protocol, and then the data server with S3 and DB, it sends the queries to the S3. Now more about saving. And the data server knows when they get a query, and they report that no one came here for a long time, so it is time for me to rest. And it sends this information to metadata server, which will remove the data from the server. So what issues have we encountered as we were doing this? The implementation was done with Java because Java and garbage collecting and Arrow doesn't have that. It has buffers. Then so it the Arrow and Java don't match well, and we are using the buffers, and we have to handle the memory in a specific way. This is why we have the allocate buffer, and we should have the root allocator. There is a whole hierarchy of those allocators, and you should create a certain size allocator hierarchy. And for example, this is the code taken from DB documentation, and here they show how they create it, and they're doing it for demo purposes. But there is no allocator there, root allocator. If you don't have root allocator, then they will use max value, and it means you will be out of memory unless you control it really tightly. So you always have to control this, and also to clearly indicate how much memory it needs. And DuckDB is in memory, and it's not in Java. And here we have the same thing. We launched DuckDB. We created a connection, but outside JVM, it does something to the memory, and you somehow have to control that, to monitor that. And you have to calculate how much is needed to set the cap, and also remember the parameters, like the streaming of results. If you don't use it, then with big data, there will be out of memory because everything will be downloaded in the memory straight away. And there is a comment from developer of DuckDB. At the moment, this is expected behavior. Not everything in DB respects the memory limit yet. In the future, this will change. So not everything is compliant with the memory limit yet. Sometimes they can cross this memory limit. You have to bear this in mind and add additional memory as a buffer for this. And we try to do that through trial and error with our queries. And we identified that this is the distribution that is good for us. And it doesn't create any out of memory or anything. And we have to work with max direct memory 10, and you don't need more, and the rest is for a heap and other regions that GVM has. The next issue we faced is the issue of too fast server. What if we have a slow client and they cannot handle the whole set of data? We had a stream, and very fast the stream just stops. What happens then? The server will be stopped, and it will keep the memory in the buffer. And then, if you don't monitor that, we have several. We used all the memory.
So therefore, one needs to have back pressure strategies, right? So this is an example of an entity that is embedded in Arrow Flight. You can create an entity, you can register it there. So this is a standard start listener with the buffer, right? So we embed it there, and we wait for the client to be ready for timeout of sorts. And if the client is ready, then we send it, and then we finish it. But not all of it is as simple as it sounds.
Надо делать через создание отдельного потока.
In reality, you have to do it by creating a different execution flow. And if you do that, then you'll have no problems. So we added this execution submit function and then kept everything the same. And we check the client readiness before we upload it, in order not to keep any extra things in the memory.
Zero copy.
This is the way it works. Other nuances, zero copy. If you go to Aeroflight site, they'll tell you that they have got zero copy, all is good. Well, there is actually a tumbler for zero copy in practice, because by default it doesn't work. And this tumbler exists in two spots. In gRPC listener, and you have to author a flag. Or that will take care of it globally speaking, or if you need it locally through a method. And then again, there is a nuance that we don't see in the documentation, but we only can see it in the code, and you have to dig in for it. Namely, if we start using true zero copy, then the bufferized entity in the root where arrows are stored has to be allocated new, right? Otherwise, it will rewrite into the same address. And the practice shows us that the allocation is decreased by 2 after we switch this function on.
Вот этот как раз момент. То есть
this is this moment
сделали true, да?
code-wise. So when we turned it on, that is to say, gave the true value to it, we have to put an extra line, allocate new, after put next. Then it will be a safe zero copy. Okay, so let's draw some conclusions. What did we have in the end? Together with the Kubernetes operator, we managed to create an economical approach when everything is created as soon as query appears. So we have a data server which starts using RAM, and when the query has gone, it stops using the RAM. If we start implementing Aeroflight and DuckDB on Java, then we get all the problems of kind of lost in translation things, because they're different languages, different paradigms, and both language works with the memory differently, and we have to control this. So we have to calculate the max direct memory. We have to control the container. If it's a Kubernetes, we don't have this opportunity not to put a limit. Limit has to be placed there. In order not to be out of memory, we have to monitor memory very keenly. We cannot forget that the client can be slow, and his slowness should not impact our realization implementation. And the zero copy, again, it sort of is present, but not quite. So we have to control that too. All right, so this is what I had to say.
Ну что, теперь можно задать вопросы?
All right, now is the time for questions. Do you have any? Well, if you don't have any questions, I will ask one. Okay, it's a setup. It's not. All right, Dmitry was telling us about the slow client and about zero copy. Can you tell us how you got there, right? What steps did you take when you realized the zero copy doesn't function? Oh, zero copy. Okay. Well, I found the zero copy issue during the process. You look at the AP, and it tells you set zero copy, and by default, its value is false. And we thought that it's because of the slow client. Yeah, in practice, it is because of the slow client. It's just that the flow was blocked up until the client, while the client part was being computed. It all happened during the development phase, when the connection between the machine, kind of the mainframe, and the local part lagged speed, and when the reading on the client side was much slower. No more questions from the audience? Then maybe I will ask a question. We're not going to give you the second prize. Oh, I don't need any prizes. I noticed one interesting thing, that there are some specific things that you have to do after the zero copy that were not mentioned in the documentation. Could you tell us whether you discovered this before the fuck-ups or later? Before. Well, I don't think I was entirely sincere there. There is in Java document mentioned, but it's kind of very implicitly described there, right? Just don't forget the allocate new. Oh, allocate new, it makes sense, right? But it's very strange for Java that you can write on top of it. Yeah, well, thank you for those who put it into Java talk. Oh, Eugene wants to ask something. Yeah, I have a question. Why is it not on Rust? Why is it on Java? Kotlin is even worse. Okay, all right. We've got Kotlin stack historically. the way it's been.
Я не знаю, не КХДБ, например.
Yeah, why is it
Потому что Олег сказал.
DuckDB and not KHDB? I think Oleg already mentioned that.
Ну что?
Тогда пауза до следующего доклада.
Okay, small pause before the next speaker
Далеко.
comes up. Please do not go far. Let's all stay put.